How are you?
I'm fine.
How are you, Doris?
We are fine.
Hey, good. Thank you for meeting in on this platform. I'm so glad to have you here.
Did you unmute yours?
Doris, since you're the first person to meet here to talk, you will take us through the opening of this session. We are opening it with a prayer. So you read us through a small prayer, then we start the lesson right away. Can you pray for us?
Oh God. Guys, humble yourself and we pray.
Okay, please.
Oh Lord Father, we thank you for the gift of life. We thank you for the gift of everything. God, we thank you for everything you have provided to us. Oh God, as we are going to begin our physics lesson, we hope you to guide our teacher and guide us in what we are going to study so that we can get. In Jesus' name I pray.
Amen. Thank you so much. Thank you so much for the prayer. It was wonderful and marvelous. Today, we are going to discuss our first lesson, that is physics. Allow me share my screen with you. Allow me share with you my screen. Allow me share my screen with you. Hello, Mr. Charles.
Yes, please.
I have a problem here.
Yes, please. Let me know quickly.
Host disabled participants screen sharing. I think it's you who did that.
Screen sharing.
Can you enable me? Yeah. Can you enable me to share my screen?
Okay. Let me see. Okay. I have.
All right. Thank you so much.
You're welcome.
Let me share my screen. Okay, do we all see there?
Yes.
Thank you. We are starting with a brief introduction. Where we are now, we are in Christian School Owners Association e-learning platform, which is being supported by ICT Teachers Association, ICT Teachers Association of Uganda. ICT teachers are those who are doing computer. They are an organization trying to make everything digitalized. We have a sponsor, or we are getting support from Edify Uganda. So they thought it was wise for us to study at least something while in this lockdown. That's why they came up and said, why can't we tell Ugandans? And really, they are doing wonderful work. I really appreciate you for joining the class. And please, don't get this thing and you sit on it. Inform others. Once you get something good, make sure you also inform others. Let others also enjoy from it. My name is Teacher Alera Daniel. I teach physics and mathematics, but I will be handling only physics at this point. I like dealing with the senior ones. Senior ones are the most interesting people I've ever met. Actually, when I'm in a senior one class, I enjoy it more than any other classes which I move to. Let me hope I will also enjoy this one. Is that okay? Will I enjoy the class? Jemima? Jemima? Hello, Jemima. So my contact is right there. Jemima, can you hear me? My contact is just right there. And that's my email for any other information or inquiry. You can get there. Good. It is Senior 1 physics lesson. Topic which you are going to discuss now is density of a substance. Density of a substance, and the facilitator, I've told you, I'm Daniel Alera. I believe we have already covered some measurements where you had the definition of measurement and you measure some quantities. We said any quantity which can be measured is what we call to be a physical quantity, a quantity which you can easily give it a value, that it can be measured and estimated. It's called physical quantity. I guess you measured length, you measured area, you measured volume, you measured volume, and so on. So, today, I want us to discuss density. Is there anyone who knows anything about density, please? In my class, we normally discuss, we make it interactive and interesting. Is there anyone who knows anything about density? Let me say the definition probably. If you're there, please say yes. Hello? Okay, there's no answer yet. Emerson Okabo. Okay, fine. Let's see the definition of density. When we are defining density, we say density is the mass per unit volume of a substance. Mass per unit volume of a substance. That is what we call to be density. When talking about density, we are talking about mass and then the volume of a substance. Who can define for us mass? Hello. Who can define for us mass? Emerson? Emerson, can you define for us mass? Shama, can you define for us mass? Shama? Shama? Yes, yes, Emerson. Emerson, you can give it to us. Mass? Yes, Emerson.
Yes, mass is the quantity of matter contained in the body.
Very good, very good, very good, very good, very good. Mass is the quantity of matter contained in the body, or the number of particles that a body contains. That's what we call to be mass. What about volume? Who can give us volume? Wesley, can you define for us volume? What is volume? Yes, Emerson? Emerson? Emerson, what is volume? Emerson, it's okay, but volume is the amount of space occupied by an object, that is volume. So when you're defining density, we are talking about volume and mass. So you're saying that it is the mass per unit volume of a substance that is density. So when you're talking about density, we are talking about the number of particles which are present in a unit volume. How many particles are in 1 centimeter cube of a cuboid? How many particles are in 1 meter cube of a substance? That is what we call to be volume. So the number of particles per unit volume of a substance is what we call to be density. What is the SI unit of density? What is the SI unit of density, friends? Doris, what's the SI unit of density? What's the SI unit of density?
I'm not sure.
Very good, Shama. That was great. Wow. It is per cubic meters. Very good. That is the SI unit of density. So we go ahead and say density is given by mass divided by volume, and the SI unit of density is kilogram per cubic meters. And just like any other physical quantities, density, which do have other units, density also have other units. Apart from kilogram per meters cubed, density can also be measured in gram per cubic centimeters. Now, when do we measure density? When do we measure density in kilograms per meters cubed? We measure density in kilograms per meters cubed if the mass is in kilogram and the volume is in what? Is in meters cubed. And we measure it in grams per meter centimeters cubed if the mass is in grams and volume is in centimeters cubed. That is that. Good. Let's write that a little bit faster. Let's put it down. Say density. The heading is measuring density of a substance. Then by definition, you say this is definition. Density is defined as the mass per unit volume of a substance, i.e. density equals mass over volume. Then the SI unit of density is kilograms per meters cubed or grams per centimeters cubed. That is that. You need to know about that. There are so many interesting things about density. When we have knowledge about density, we can use it to explain very many things. One, importance of studying density. Importance of studying density, one of them, it helps in comparing two different substances. That is one. It helps in comparing two different substances. I have a question for you. Bliki Chimera, do you hear me?
Not well.
Not very well.
Yeah.
I was directing this question to you. Do you see that the two diagrams on my screen?
Yes, you can see.
This and this, okay?
Yeah.
The two figures are having the same sizes. No, sir? Are they having the same size?
Yeah.
Good. How many? Do you see the number of particles in this?
Yes.
And the number of particles in this one? So we realize that the number of particles in this one is more than the number of particles in this. Much as they have the same size, this is the box, they have this, the size of this is the same as the size of that. But you realize that the number of particles here are not the same as the number of particles this side. So, Blicky, if I'm to ask you, if you ask to carry this box and this box, which one would you feel like is heavier than the other?
The second one.
The second one. Very good. Remember, they have the same size, but different capacity, different number of particles. And so, we call this to be less dense. We call this to be less dense and this one to be more dense.
Yes.
So if I ask you, between the two, which one is having greater density than the other?
The second one.
Very good. The second one is having greater density than the other. So, we may have different substances of the same size, same volume, but there is a possibility of those substances not to have the same weight, not to weigh the same. Why? The number of particles in them are different. If I may ask, if you have a polythene paper filled with air and a polythene paper filled with sugar, and in this case, they're all polythene papers of the same size. Which one will be heavier than the other? Blicky?
So there is noise in the background.
There's noise in the background.
Yes.
Oh. Let me work on it. Good. So I was still asking if you have a bag of hair and a bag of sugar, which one is heavier than the other?
Teacher, pardon.
A bag of a polythene bag filled with air and a polythene bag filled with sugar. Which one is heavier than the other?
The one with sugar is heavier than the one with air.
And what is the reason behind?
Air has less weight than sugar.
Good. The difference comes in the densities, the number of particles of air molecules are very few compared to the number of particles of sugar which are in the polythene bag. So that makes that of the polythene bag, that makes the polythene bag of sugar heavier than that of air. So we use density to compare different substances. We are saying an object may have a smaller size than the other, and yet it's heavier. It may also happen that two objects may have the same size, but one is heavier than the other. They are the same size, but one is heavier than the other. They have different sizes, one is heavier, the smaller one is heavier than the other. So what brings about that is what you're calling to be density. Like if you see a kilo of maize flour, a kilo of maize flour and a kilo of sugar, do they have the same size? Bread? Hello, bread? Nicholas? Hello, Nicholas? You unmute yourself and talk. Nichols? First unmute yourself and talk. Okay, now you can talk. Good.
Yes, I'm trying to connect.
You have lost him. It's okay. Gillian? Gillian, are you there? Okay, but the truth is, when a kilo of sugar cannot be the same, size as a kilo of what? Maize flour. The maize flour, the particles are less dense compared to a kilo of sugar. So it just very good. Good. So we use densities to compare substances. Then, number two, when you see this diagram, we are trying to compare different liquids. We have syrup, we have fruit juice, have water, and alcohol. Do you see my screen well?
Yes.
Yeah. Those one on top, those which are on top, they are less dense than those at the what? At the bottom.
The bottom.
Yes, exactly. So here I say syrup is heavier than fruit what?
Fruit juice. My God. What's happening?
Yes, please. Teacher Daniel, are you there? Teacher Daniel, are you with us? Okay, I think his network is very unstable. Yeah, good morning, learners. As Teacher Daniel will come on board, this is Teacher Charles. Yeah, I'm the admin for the senior 1 and then senior 2. So as he comes on board, I've been observing your lesson very well, and he has been teaching very well. But on the side of the learners, guys, I would like you to really be very, very attentive here. Please, one, you mute your microphone. If you're not talking, mute the microphone, because we do not want to get your background noise. Remember what is taking place. The whole world is seeing and the whole world is actually hearing. So guys, I would like you to be very, very, very critical of that. Then too, your videos, yeah, when you enable your video, everyone is seeing you. All the people who have joined the meeting and even some other people will be seeing you. So you need to mind about that. Ensure that your video is always off, and unless otherwise, if the teacher is there telling you that you put your video on, but it's always by default, it should be actually off. Is it okay? Is it okay? Guys, can you hear me? Can you hear what I'm saying? So learning cannot take place in a noisy environment. We cannot have a learning where people are making noise, people are showing videos. Learning cannot take place. So we are all learners, and I'm also a learner. That's why I'm attending the lesson. So when you see all my videos, my microphone is off. So always mute. I hope you know how to mute your microphones. When I ask you to talk, you'll be able to talk. Is it okay? Guys, that's what I want. Is that clear?
Yes.
Yes, mute
Yes, sir.
microphone and also disable your videos. Yes, the teacher will come back. I'm actually getting in touch with him. He was talking about density, which is something very good. So he introduced the topic density. I know most of you are aware of it. You know what density is all about. Yeah, so when he comes on board, I'll be able to, he will be able to continue from where he has stopped. So this call is being recorded. Yeah, so no one should just say, teacher, can I record it or what? Don't record the lesson, because I'm already recording it. I'm an admin here. I'm doing what it takes. So sometimes I'll be muting you. I'll be unmuting you. So please, what I want is order here in the room. Is it okay? Is it okay?
Yes.
Yes.
I need maximum attention
Yes.
so that learning can take place. Okay, let me get in touch with the teacher quickly.
Record.
Tugenda already oli mu class bali awo ne topic gye baliko sinabitegeera ojja sooka consulting oyo yebaweereza.
I got an interruption. Very sorry for that. Mr. Charles?
Yes, Teacher Daniel, thank
sorry.
you so much for joining. Yeah, I was here with your learners. I was actually talking to them about the protocols to be observed in the lesson. We shall be going over, we shall be teaching different lessons here. So I request all of you, even the teacher, that the background noise should be something that is should be minimal. Now, like where I'm teaching, you can hear that the background noise is minimal. You cannot even hear anything. So please, let's observe maximum silence in the when we are doing our lesson. Otherwise, thank you so much. You can continue with your lesson.
Okay, please. So we are comparing some liquids. We are comparing some liquids. We compare to fruit juice, water, and alcohol. From here, we can conclude that alcohol is the least dense among the rest of ions. Reason being, it is floating on the surface. So the fact that it's floating on the surface, that it is the least dense among all the. Then the most dense one is syrup. Is the more dense because it's already sinking down. So from this diagram, we make a conclusion that for something to sink in water, okay, for you to have something sink in water, it must be more dense than water. Is that clear? Doris, is that clear?
Yes, teacher.
Good.
Yes.
Can you give me an example of anything you know which can sink in water? Doris?
Pardon,
An example of any substance you know which can sink in water.
a stone.
Very good. A stone can sink in water. What does that one tell you? It tells you that the density of stone is more than the density of water. Do you hear that?
Yes.
Yes, Emmanuel, I see your hands up. You can talk to us, Emmanuel. Emmanuel, unmute yourself and you talk to us. Emmanuel, unmute yourself and you talk to us. Oh, we can't hear you. So a stone is an example. Who can give us another example? Mr. Agaba, can you give us an example of any substance which can sink in water? Agaba?
Keys.
Sorry?
Keys.
Very good. Key is made out of iron, so it can sink in water. So we say that a key is denser than water. Blicky, can you give us the last one? Blicky? Blicky? Or Arosta Alima, can you give us the last one? Alima? Sorry?
Metals.
Metals, kettles, very good, very good. So those are the examples of substances which can sink in water. But we don't want to know that. But what we want to know from here is that when it is sinking in water, it means that it's more dense than water. When we have cooking oil floating on the surface of water, it means that cooking oil is less dense than water. When we have paraffin floating on the surface of water, it means that paraffin is less dense than water. When we have a boat moving in water, floating on the surface of water, that means that a boat is made up of materials which are less dense than water. When you see a log or a piece of wood floating on the surface of water, it means that the wood is less dense than water. Let me hope we have got the implication of densities. Good. So continuation of another example. Knowledge of density can help in explaining some.
Teacher Daniel, can you
Yes.
hear me? Yeah,
Yes, I can hear you.
There is still noise coming out of your background. You can minimize it, just help us and you minimize it a bit. Thank you.
Okay, please. So we are saying knowledge of density helps to explain why some objects float on water while others do not. We have already seen that. So you're saying an object sinks in water if its density is greater than water. This explains why iron can sink in water while large piece of wood does not. Is that okay, everyone?
Yes.
Good. Let us write that knowledge number 2. Let's write it very fast down. Let's be fast when we are. Let's write very fast. Are we done? Are we done? Somebody let me know.
Yes.
Very good, thank you. Thank you. We have density of some common substances. This one you not write it. There's no need of writing. Density of some common substances. We have water, which is at 1 gram per centimeter cubed. We have magnesium and so forth. What do we mean by saying a density of water is 1,000 kilograms meters cubed? We have already defined density. We said density is the mass per unit volume of a substance. So being mass per unit volume, if we say the density of water is 1,000 kilograms per meter cubed, it means that the mass of 1 meter cube of water, the mass of 1 meter cube of water is 1,000 kilograms. The mass of 1 meter cube of water is 1,000 kilograms. Or 1,000 kilograms of water is expected to be equivalent to 1 meters cubed. You can be writing that. So 1,000 kilograms of water is expected to be equivalent to 1 meter cube. as the volume. Or the volume of 1 meter cube is the same as 1,000 is equal to 1,000 kilogram per meters cubed. When we say the density of copper 8.96 gram per centimeters cubed, means that 1 centimeters cube of copper is 1 gram only. One something very, very small. When you have 8.96 gram, we are saying is the same as 1 centimeters cube. Only that. So that's the meaning of density. When you talk of the unit of density being in kilogram per centimeter per meter cubed. Good. We are in class. Please feel free to ask any question, please. Feel free to ask any question in case there's something you have not got well. We are here to help each other. So feel free to ask anything you feel like you need to know into details. Is that clear? Alima, is that clear? Very good, very good. So don't say that is the teacher, so is the final. No. You ask question in case you have not got anything well. I'll be very free to repeat it for you.
Excuse me, teacher.
Okay.
Can you please repeat on the point when you said that when we said that
Yes,
the density of copper
please.
is 8?
The density of copper is 8.6 gram per centimeter cubed, and we mean that 1 centimeter copper weighs 8.96 gram. Okay? It means that 1 centimeter
Yes.
cube of copper weighs 8.96 gram. Is that clear?
Yes.
Is that clear? Very good. Okay, Povia, your name is very complicated. How do you pronounce your name? Pova 3 here. How do you pronounce your name? Pova, how do you pronounce your name? Good. Let's move to finding density of a substance. I have a simple question for you all. Now that you know density, that is mass per unit volume, if I asked you to find for me density of a stone, okay? If I asked you, please, here is a stone. Get for me density of a stone. We don't have an apparatus or a device which can be used to measure the density. So, can somebody tell us how to get the density of a stone? Who is there? Who is there to tell us how to get the density of a stone? I've given you a stone. I have provided you with every other thing apart from the instrument for measuring the density of a stone. Can you get for me the density of a stone? Melody? Aha! Good. Pova, you can tell us. First unmute and then you tell us.
Divide the mass by its volume.
Wonderful, 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 wonderful. Let me hear another one from Jillian. How do you get it? I've given you a stone and I want the mass. I want the density. Gillian?
We use displacement method.
Displacement method. Can you elaborate? Just simple, something small there.
What?
Okay, Gillian. Don't worry, we are getting back to you. Let me hear from Blicky Kimera.
Put the stone in water and it overflows. The water
Blicky?
overflows. The water overflows. The water. Put the stone in water and the water.
Yes.
The water in the.
Yes.
Put the stone in water and the water overflows.
Press unmute. Come on, I press for him. Press come.
Okay.
Here. Now you speak.
Put the water in.
Yes. Oh, Blicky, feel free. We are in class. Don't worry. We are in class. Feel free. Talk to us. Don't worry. There's nobody who will say that your answer is not correct or correct. Don't worry.
Put the stone in water and the water overflows.
And the water overflows. Okay. We have got you. Thank you so much. Thank you. Today we are going to see how to get the density using calculations. But for us to get the density, we need to get the mass. We measure the mass of the stone. Which instrument is used for measuring the mass? Raise up your hand, please. Which instrument is used for measuring mass? Yes, Gillian. Gillian, unmute yourself and you tell us. Instrument is used for measuring mass.
When we are using displacement method.
Displacement method. Oh. I was asking Gillian, which instrument is used for measuring mass?
A weighing scale.
Weighing scale, very good. Very good, very good. It's a weighing scale. Yes, Emerson, which instrument do you know? Emerson? Okay. But we have weighing scale, we have an electronic weighing scale, we have triple beam balance, which you can as well use for measuring the mass. Emerson, do you still have, are you still around? Yes, you can tell us. Sorry?
The beam balance.
Beam balance, very good. You can as well use the beam. Yes, I've got you. You can as well use the beam balance. Good. Now, the question here, how can we find the density of a substance? You need to use the beam balance to determine the mass. Then you also need the volume. You're going to see that experimentally in the next lesson. So it's saying that to find the density of a substance, you need the mass of the substance and its volume. That is one. Two, you'll get the density using the formula. Density equals to mass divided by volume. Is that clear? Is it okay? Very good. Gillian, your hand is still up. Yes, I see the sign. That's great. Let's see how to determine density by calculation. We have question number 1. Doris will read for us that question. Doris, can you read for us the question?
The mass of 24.4 centimeters cubed of mercury in 332 grams. Find the density of mercury. That's part A.
Very good. So we have the mass of mercury, which is 24.4 centimeters cube. And they're saying that it weighs 332 grams, and required is for us to find the density of mercury. So if they want the density of mercury, you said if they want the density of mercury, for us to get the density of mercury, we have just seen behind there that we need the mass and the what? And the volume. Then we get the mass and we divide by the what? By the volume. Is that okay?
Yes.
Good. So, if they want the density of mercury, we need the mass, which is already 332 grams, divided by, we also need the volume, which is 24.4 centimeters cubed. So in our solution, you first write the question down. Write the question down. First write the question down. Are you done?
So we are done.
Okay. Good. So let's see how we can get the density of mercury. To get the density of mercury, the same solution. We have been given the volume is 24 centimeters cubed, and we have been given the mass of 322 grams. I think there is nothing missing for us to get the density. So just say from the formula, mass, density equals to mass divided by volume. That means that our density will be mass, which was 332 grams, divided by volume, which was 24.4, which gives us what? 13.6 grams per centimeters cubed. Do you see that?
Yes.
Very good. So can we write that? I don't want us to go to part B before we write that down.
Yes, Teacher Daniel, can you hear me?
Yes, please.
Okay, if possible, I'm seeing we're left with just 2 minutes to close this session. If you are prepared some exit ticket, you can give the learners so that they go and now they try. Then after, maybe they will submit their results to you, but we are also making Google Classroom operating. That's where the learners will be submitting their work. But the details about the recording and also the presentation will be shared to the learners on their WhatsApp group. Yeah, so you can just wind up. Thank you so much.
It's going to be shared, okay?
All right, fine, no problem.
So-
I have everything.
Okay.
Yes.
Teacher, what's the WhatsApp?
So let us wind up. So I will share this, we shall share this work on our WhatsApp group where you'll be copying direct from there. Is that okay? We shall add you there. We shall add you there. We have your contacts. Good. What is part 2 saying? Let us wind up with this number. What is part 2 saying? Read for us part 2, part B.
Go back to the page. I didn't copy it.
The volume of mercury which would
weigh?
Find the volume of mercury which would weigh 150 grams.
Very good. So the density of mercury is already here. As you see, this is the density of mercury already. So the volume of mercury which would weigh 150 grams. So the density of mercury here means that 1 centimeter tube of mercury weighs 13.6 grams. So in our solution to part 2, density of mercury is already this, 13.6 grams per centimeter cube. So this being the density of mercury, that means that if this is the density of mercury, that means that 13.6 grams of mercury weighs, occupies 1 centimeter cube. What about the other 150 grams which they were talking about? What will it occupy?
2.
So what about 150? It will occupy 150 times that, which is 11 point that. Or there's another option. Or you can say from density equals to mass over volume. If density equals to mass over volume, that means that our 13.6, which the density, equals to the other mass which they talked about. 150 divided by the volume V. So when you cross multiply, you will get 13.6 times V equals to this. So that means that 13.6, V equals to 150 divided by 13.6, which gives us 11.0296 centimeters cube as before. So that is it. Who can read for us part C?
Given that the density of water is 1 gram,
Yes.
would mercury floats on water if it was poured in a beaker containing water? Give reasons for your answer.
Good, thank you. Thank you so much. So we have already seen the density of mercury is 13.6 gram per centimeter cube. And we are saying that the density of water is 1 gram per centimeter cube. The question is, can mercury float on the surface of water? Who can give us the answer?
Yes.
Can mercury float on the surface of water?
Yes,
Give the reason for your answer.
because mercury is less denser than water.
Let's check the density of mercury. Do you see the density of mercury?
Yes,
It is what? Do you see 13.6, okay? Is that fine? Hello, do you see the density of mercury is 13.6 and density of water is 1 gram per centimeter cubed?
Yes.
Which one is less dense than the other? Okay. Who is there? Doris? Doris? Oblique? So mercury is 13.6 gram per centimeter cube, that's its density. And water is just per centimeter cube. So mercury is more dense than water. So it is not able to float on water. Is that clear? Is that clear? Okay. So part C, mercury would sink in water. This is because from the calculation, the density of mercury is greater than that of water. So because of time, I'm going to give you some trial questions on the, we will have this activity. Do you all see the activity? See the activity?
Near where where I showed you at, which is your name. Yes.
Oh.
I'm speaking. Your video is not when the clay is speaking. How about
Hello.
yes, teacher.
There is an activity there. Do you see it?
Yes.
Can you write it very fast? Because we are ending the lesson. Write it very fast.
Okay.
Doris is speaking. Doris. It's Doris, but you need to get her book. Ask him.
When you're done, you let me know. You done? You calculate that. Part 1, part 2. Part B is that.
I'm sorry,
Are you
but
done?
I'm not seeing. No,
Sorry.
I'm not seeing it.
On my screen.
As
Okay, you
I've
first.
seen.
you can disable your video, Teacher Daniel, and you make it bigger for them to see. Thank you.
Do you see it?
Yes.
Alec, okay. When you're done, you let me know, okay?
Yes.
Good, good. Are we done?
Yes.
Good. So that's the only number which you're going to do. I want you to do it. After doing it, we'll submit it for marking on our Google Drive. Okay? We'll submit it for marking on our Google Drive. Add part C. Do you see part C?
Yes, teacher.
Yeah, you add it there. So we shall continue from there in our next lesson, okay? We shall add more examples in the next lesson, then we shall see other things in the next lesson.
Okay, Teacher Daniel, thank you so much for the wonderful explanation. I understood, ever since I did not understand density, but I've understood now today. Yeah, today I've understood very well. So I'm going to ask Jillian. Jillian, can you pray for us for the lesson so that we end in faith? Jillian, can you unmute and you pray?
Okay, come back. Most gracious Father in heaven, look after us as we go for the next lesson, oh Lord, Father in heaven. Father in heaven, enable us to be good and obedient children. Protect us from danger. Enable our teachers to be proud of us. All this I ask in your name. Amen.
Amen. Thank you so much. Thank you so much, Jillian, for the wonderful prayer. I am very, very impressed. So if we do the work, we shall continue from there in the next lesson from where we have stopped. Thank you so much. Thank you so much. Goodbye.
Should we have another meeting?
Thanks for teaching.
Okay, please, please, love you all. Thank you too. Thank you.
Bye.
Bye. Mr. Charles?
Bye.
Bye.
Thanks for teaching.
I'm around. Thank you so much.
Thank you.
Guys. Thank you, guys. Enjoy your you enjoy your day. Check the timetable, please. Check the timetable. If you do not have a copy of the timetable, we shall give you through your WhatsApp group. We are sharing the timetable, as you know.
Charles.
Yes, please. I'm here.
Charles, I want to remain with you here.
Yes, I'm around. I'm around.
Let's wait.
Yes,
Let's wait for students to go.
learners, you can leave. Yeah, you can leave the lesson as ended. Check the timetable for your next lesson. Thank you so much.
Learners, you can leave.
Bye, teacher.